The same thing again, but just click on raise your hand if you can hear me loud and clear, and that'll just set my mind at peace. Good. I'll talk a bit more so that you can check to see whether you can hear me. There's a few people who haven't raised their hands yet, but I've got a few who are okay in there. Brilliant. Okay. Right. Is anybody who can't hear me? Let's try that. If you could just go up to the same little tick box and just click on disagree up the top there if you can't hear me, and then at least I'll know everything's okay. Right, no one's clicked that so far. Okay, so let's go. Right. Well, welcome to part 2 of primary computing. And we're going to be, last session we really looked at terminology and all of the sort of terms and what they mean and how we can sort of understand them at a primary level. And this session we're going to really sort of move on to look at algorithms and programming and what type of programming languages to use, what type of unplugged things to use. And then we're going to go into all sorts of things like assessment and all sorts of issues there. Of course, if there are any issues that you want to ask me as you go, please do just type them in, and I'll do my best to answer them. I've put my webcam on today, so I can just I've got a few bits and pieces here, so we can get a bit of interactive and show you some things as well. Okay, here we go. So I think it's probably worth saying before we sort of get on to looking at different programming languages, the relationship between programming and algorithms. One of the things I find is that people often don't really understand how these two sort of click together. They understand that an algorithm is a step-by-step guide, a precise step-by-step guide to achieving something, to sorting out a problem. Okay, and they also understand a little bit about programming, that you're making something happen through step-by-steps. And I think it's worth saying that all successful programs are also algorithms. Okay, so when your children use a programming language, they are also creating an algorithm at the same time. All they're using, though, when they use a programming language, is they're using a specific language to actually do that. Be that the language of something like Logo, with its forwards and rights and lefts and repeat commands. Okay, or it might be using the language of Scratch with its blocks and its things that snap together, or it might be using the language of a more formal programming language like Python, which is all in text. Okay. Of course, an algorithm's a little bit bigger than this, because with an algorithm we're using human language, so we're using understandable language that people can read and follow, and that it doesn't have to actually work on a specific device. Okay, and that's why, in this little illustration here, we have algorithm being a little bit bigger than programming, because programming is in some ways a subset of algorithms. Okay, so it's just worth understanding that really before we sort of get on to look at things, because I've actually had people say to me, "Oh, I love what your children have done with an aspect of programming. What was the algorithm behind that?" And I thought, well, actually, that's really you just not understanding what an algorithm is in some ways, because actually the program they created, as long as it works, actually is an algorithm. So worth saying that. Okay, let's move on. I think it's worth sort of talking about the sort of primacy of programming and algorithm design in both Key Stage 1 and Key Stage 2 this evening. So here we've got the sort of Key Stage 1 computer science programming elements and algorithm elements, which we said are very related anyway. So we've got pupils should be taught to, and we've got this bit in the middle, create and debug simple programs. Okay. And then we've got these bits above and below, which are almost like the burger buns, really, which is sort of part of. And I would explain this a little bit like the meat in the middle of this is the create and debug simple programs, but you also do these other things while you're creating and debugging simple programs. I'd probably extend it a little bit and say create and debug simple programs and algorithms so that it just covers it a little bit more. So, you've got the sort of first bit of the bun here. Understand what algorithms are. Well, do children get that it's a set of commands that achieve something? How they're implemented in programs on digital devices. Well, the idea that algorithms and programs are all running all the time that we're using all of this equipment, our laptops, our PlayStations at home, the mum's phone, the iPads, all of those things, that actually it is running a set of programs all the time, and that these programs are algorithms, sets of instructions that do something. And that programs execute by following precise and unambiguous instructions. That you do have to be very precise. And I know, if those of you here for part one, a lot of that precision when we did some of the stuff around the jam sandwich, we were focusing children in on the fact of the need for precision there. Okay, and ambiguous, that you have to, the other person has to totally understand what you're doing. This is one of the reasons why things like the logo language is so useful, is that it is very, very unambiguous. Forward a number, or makes exact sense to a computer, or if a children's talking about it, forward 10 centimeters makes sense to them as well. And then, of course, we've got the second part of the burger, the bottom bit. Use logical reasoning to predict the behavior of simple programs. And in Key Stage 1, we're really talking, when we talk about logical reasoning, and I'll just refer you briefly back to some work I've got on my website here with computer science terminology for teachers, which you can get from my website, which is code-it.co.uk. And there's I've written an explanation of logical reasoning here. So it's the application of rules to problem solving. Okay, and in fact, these rules can be about anything, really. Okay, so do children understand that there's a set of rules that go with the things that they use? Okay, when they're programming. I will often explain this when I'm looking at this for logical reasoning in Key Stage 1. Do children understand that actually something like a bebot, and we have one here. Okay, a bebot only has a certain limited set of instructions that we can do. We can go forward, we can back, right, left, etc., etc. We can go, and it also has a certain distance that it goes each time. So that's part of its set of rules. Whereas a child who thinks that the bebot can go a tiny, a centimeter and then stop and turn 10 degrees, really is not understanding the rules that govern this. Okay, right, let's go flip back again and go into there. So that's the sort of Key Stage 1 sort of programming burger, or how I like to think of it anyway, for all of us who are trying to save a bit of weight more. So lose a bit of weight after Christmas is probably not maybe the best analogy, but there we go. Okay, in Key Stage 2, it's sort of trying to keep with the same thing. I've got the programming sandwich with internet side salad. So something like this top bit here, we have the design, write and debug programs that accomplish specific goals. Okay, if anything, I tend to think of this first little bit as the most important bit, and then all these other bits. In fact, I should have really moved the burger bun up a little bit. Don't know why I haven't there. Anyway, something for next time. So I would say that this. Let's go back to that one. Okay, go out of it for a second. So this little bit here for me is the most important bit for us. Okay, designing and writing debugging programs and algorithms, I'd say, and let's put that in as well, that accomplish specific goals. And then of course all these other bits. In fact, let's be really cheeky here and just grow that up a little bit more. There we go. I'm gonna let's stop there now. And